Okay, so picture this. A towering iron pillar, standing tall for over 1,600 years. It's weathered storms, scorching sun, and it hasn't rusted. How is that even possible?
Yeah, that's
That's the mystery of the Iron Pillar of Delhi. And believe it
yeah,
or not,
incredible. Yeah,
the answer lies in the fascinating world of everyday chemistry.
it's true.
We're diving deep into a seventh grade science book today, but trust me, this is about to get way more interesting than middle school science class.
You're right. This isn't about memorizing the periodic table. It's about understanding how the fundamental principles of chemistry are at play all around us, even in something as seemingly simple as a rusty nail.
Exactly. The textbook we're looking at today starts with those relatable examples, dissolving sugar in water, setting curds from milk. These are things we see every day, but have you ever stopped to think about what's actually happening at a molecular level?
We're talking about the difference between physical and chemical changes.
Mm.
Physical changes are like rearranging furniture. You're changing the appearance, the form, but the basic components are still the same.
So like ice melting into water, it's still H2O, just in a different state.
Exactly. And just like you can refreeze that water back into ice, many physical changes are reversible. Chemical changes, on the other hand, are more like taking those furniture pieces, breaking them down into their raw materials, and building something totally new.
Okay, so that brings us to rust, which the textbook calls out as a prime example of a chemical change. And this isn't just about unsightly stains. We're talking billions of dollars in damage to ships and infrastructure every year.
Rust formation is a fascinating chemical reaction involving iron, oxygen, and water. It's basically iron breaking down and forming a new compound, iron oxide, which is that reddish-brown flaky stuff we see.
And this is where the iron pillar gets even more interesting. It's mostly made of iron, it's been exposed to the elements for centuries, and yet minimal rust. The textbook hinted at some reasons, high iron purity being one.
Absolutely. Impurities in the iron can act like little starting points for rust to form. Think of it like this. If you have a perfectly smooth wall, it's harder for something to latch onto it, right? But even a tiny crack can give rust a foothold to start spreading.
So the purer the iron, the smoother the wall, the less likely it is to rust. That makes sense. But even with super pure iron, wouldn't you still expect some rusting after 1,600 years?
You would, and this is where the forging process comes in. The textbook mentions hot forging, but to really grasp its significance, we need to go beyond the basic definition. Imagine blacksmiths hammering that iron at scorching temperatures, not just shaping it, but also inadvertently creating a shield.
Okay.
This process creates a dense, almost impenetrable layer on the surface. It's like giving the iron its own custom-fitted suit of armor, molecularly speaking.
Oh, okay, now that's pretty cool. So we've got super pure iron forged into an almost rust-proof shell. But the textbook also mentions something about the climate in Delhi playing a role. That feels counterintuitive. Don't you need moisture for rust?
You think so? But here's where it gets really interesting. The climate in Delhi is hot and dry for a good part of the year, so less moisture for rust to form. However, they also have those intense monsoons. Now you're thinking, wait, rain.
Yeah.
And you're right, water is usually a key ingredient in rust formation.
Yeah, it seems like the pillar should be a rusty mess.
Right, but instead of completely rusting the pillar,
Yeah.
the monsoons, combined with Delhi's heat, seem to have created a unique type of rust. A denser, more stable layer that actually protects the iron underneath.
So it's like the pillar said, okay, Rust, you want to hang out? Fine. But you're only allowed on this outer layer. You can't go deeper.
Exactly. It's almost like the pillar developed its own self-healing mechanism over centuries. And it's this combination of factors, the purity of the iron, the forging process, and even the local climate, that have all conspired to make the iron pillar the marvel it is today.
That's incredible. It makes you wonder about those ancient metal workers. Did they understand this complex interplay of chemistry? Or did they just stumble upon the perfect recipe for rust-resistant iron?
That's a question that's fascinated historians and scientists for ages. The textbook doesn't delve into that. But what's important to remember is that you don't always need a microscope and a lab coat to be a master of chemistry. Sometimes observation, experimentation, and passing down knowledge through generations can lead to incredible results.
It's like they were conducting a giant chemistry experiment without even realizing it. But speaking of experiments, what about those copper sulfate crystals mentioned in the textbook? They seem a world away from a giant iron pillar.
Not so fast. Remember, we talked about how chemical changes are about creating something entirely new? Well, crystal formation is a beautiful example of that, even if it looks less dramatic than a rusting shipwreck.
So we've got this seemingly simple process of dissolving copper sulfate in water.
Which is a physical change.
Right. Just like the ice melting into water, but then as the water evaporates, boom, these stunning blue crystals emerge.
And that's the chemical change in action. The copper sulfate molecules are rearranging, bonding together in a new and very structured way, creating those eye-catching geometric shapes.
It's like chemistry's way of saying, hey, even though we're talking about atoms and molecules, we can still make something beautiful.
Absolutely. And it highlights the fact that chemistry isn't just about what we can see with the naked eye. It's about the invisible forces and interactions that are constantly shaping our world.
And sometimes those forces create a rust-proof wonder of the ancient world, and sometimes they create a sparkly blue crystal. It's all chemistry.
Precisely. And whether we're talking about the iron pillar of Delhi or a simple sugar cube dissolving in water, it's all governed by the same fundamental principles.
This deep dive has been a fantastic reminder that chemistry isn't just confined to textbooks and labs. It's happening all around us all the time.
It's the silent architect of our world, and understanding even a little bit about it can give you a whole new appreciation for the everyday wonders that surround us.
So next time you encounter something like a rusty nail or a shimmering crystal, don't just glance over. Take a moment to consider the intricate dance of atoms and molecules that made it possible.
Because within those seemingly ordinary objects lie extraordinary stories of chemical reactions waiting to be discovered.
And who knows, maybe you'll be inspired to explore the world with a little more curiosity and wonder and uncover a few chemical secrets of your own.
Until next time, keep those curiosity gears turning.